What's up guys, Shawnthebro here, and today we're going to be going over the final part for the multi-button input mini-series within the fighting game tutorial series. So what we're going to be covering today is fixing up a few minor issues with our system because input currently could not be fired on the same frame, and what I mean by that is if I fired two inputs at the exact same time, it would actually not perform either, just by the nature and the logic of our code. We do need to fix that because that will lead to some unresponsiveness, and also could be useful specifically for controller when we have to do things like quarter circle input. We will want to know where it's moving and capture its value at each frame, but you could of course also be pressing a different button. Like on the keyboard you have your keys, so I can press D for forward, A for back, and then press an attack. Sure. I can even do directional attacks using that method. However, when you're on a controller and you have the input axis of the joystick, it's got to be reading that value as well as this. And so you want to make sure that if you were to start them at the same time, say I press my joystick and attack at the same time, I need them to still be able to fire. If it's the exact same frame, which often it is, I mean in multiple cases, you can get this very, very quickly. So if I look at this, I have my log still printing in the bottom left here in the output log. You can see I have add to input buffer for press and release. It actually prints on both, depending on what it is. Like if I hold it and release it, it prints another one. See that? And so if we look at where we're at now, all right, and I'm gonna perform my throw based on the logic we set up in the previous episode. All right, so if we do that, then you can see if I press them the exact same frame, you could see these two lines right here. Add to input buffer 7634, and do backward throw. Now backward throw was heavy and light at the same time. They were executed on the same frame, and I did actually perform the backward throw. So with that in mind, you can see how useful this can be, because we need to be able to perform actions when we actually press two inputs on the same frame. Just like that. Cool, perfect. So at this point, that's what we're going to be covering today. And once we're done with this, we'll really only have two other input buffer things that I want to cover until I feel very satisfied with our system as a whole. So I'm getting very excited as we get closer to the end here of the input buffer mini-series. All right, let's go into our code. That's where all of our logic is going to be today. Feel free to, before you get started on this, check out the entire playlist. This is episode 101. We've done quite a bit in this series since we've begun to get to this point. However, we are not really near finished. If I'm being completely honest, we still have plenty of work to do. And so you might want to catch up if you're interested in following along. The playlist is right here in the top right corner if you want to check that out. Alternatively, if you just want to check out the previous multi-button input sections so that you can see how to perform an action when two or more inputs are pressed at the same time within a working input buffer system, you can check out part 1 of that series, that mini-series of the fighting game series right here. All right. At this point, we can get started on the actual logic. So the logic is pretty simple today. This is not going to be a super complicated one like a lot of the input buffer ones are. This is just going to be a few minor adjustments that's going to make a world of difference. So first things first, let's go into our fighter template character.h. Now, we need to add a few things so that we can kind of keep track of every input that gets added on a certain frame. I mentioned this in the previous episode, but it was not actually added before, so you might have seen this commented out. Basically, what we're doing here is the way our input buffer system works now is basically we have this circular input buffer, and what it is it keeps track of every frame and the input that was provided on that frame. Well, that's good. That works when you're only ever adding one input. If I add multiple inputs on the same frame, like we're talking about here, then it's going to either overwrite the input that we already added the first time around for that frame, or it's not going to add the second one. In our case, it was never adding the second one, so it's working fine regardless. If we pressed one or more, it was only ever taking the first, so it was working fine for that, but again, sometimes it would cancel out the action you were trying to do, or it would actually provide the wrong move, these sort of things. So what I've done to fix this is instead of our circular input buffer holding one input per frame, we're giving it a value, an amount of inputs that it can hold per frame. And so I've made this thing called an F input info array. We have the F input info structure here. And if you look at it, it's right here. You will already have this from previous episodes if you checked out the input buffer series. But really what this is any input that the player presses goes here, and we track all the corresponding data and the data that is relevant for the input buffer. Well, let's scroll down a bit before we get into that. And I have this line commented out, but I left this in so you could see it. This is what you saw in the past. This is what our circular input buffer looks like. Initially we had this input buffer like this. Okay, this was our initial draft. And I kept it in just to show you. You can still use it. But then we eventually moved to the circular buffer structure. Okay, and we were using an F input info. So that's what I just showed you above. However, now we want to actually do this. It's basically the same setup, but we're going to have an F input info array as the type. So for every element in this input buffer, we have 60, you can see by the parentheses here. It's not an F input info anymore, it's an F input info array. So if we look up at the structure here, remember this is F input info, so this is every input the player presses. Now I've made a new structure called F input info array, which is an array of that structure. So basically, without all the complicated stuff here, the way that I look at this is like, instead of having one input for each element in that circular input buffer, we can have as many as we want defined by this array. So we can store, for example, 8 inputs on a single frame. So if the user pressed 10 inputs, then only the first 8 would be tracked. You do want to limit it, A, because this is going to cause more looping to occur if the user is spamming inputs. And of course, the actual size is bigger of our structure here. So we don't want them to be able to capture unlimited inputs for our input buffer on every frame. 8 is probably way too many. Really, it should probably be up to like 4 or something. But for me, 8 is just a safeguard. We can always turn it down later if we find out we don't need it. I'm thinking that it could never really be more than 8 unless you're holding everything and, maybe somehow you could get it to work. But really, with all the actions we have now, 8 is a good number. Okay, and so that's what it comes down to. We're making a new structure called F input info array. I just have F input info as the type. Inputs is what I call the variable name. And when you're making an array, the way you can define its size when you initially create it, because this isn't a T array, this is just a regular array like you would make in C++. When you define its size, you can do it like this, where you have the type of element that's going to be stored in the array, the name, and then the count, like this. So the count here I've called max inputs per frame, and I've set a constant integer up above it. You don't have to do it this way. I don't particularly enjoy hard coding values, because if you need to use them in multiple places, then you have to make sure you use that same value. So if I just put 8 in this array right here, I would have to use 8 everywhere I want to access this. But that's a little bit sloppy. And if you end up wanting to change in the future, you got to make sure you change it everywhere. So really, it's easier to just make a constant integer. The keyword const here just means it can't change. It is a little bit quicker for memory reasons when accessing it. However, it's also important reading it as the developer or as a user here, because you know that this value cannot be changed. So you change it here and it changes it everywhere that we're using it. So this basically means we're making an array called inputs of F input info as the type, and there's going to be 8 elements that it can store. And now, if we go back down here, our circular input buffer looks like this. So I've gone through all these variations. We had this initially, and then we had this circular buffer, and now we have this. Now, of course, when you change this, if you try and build, you will get errors. We'll fix them in a second. But I'd like to actually go back up here where we just were and explain this a little bit more. So there is something we're doing here that you probably haven't seen before. We're actually putting this variable outside of the class. If you see, we're in fighter template character. The fighter template character class is right here. You've seen us put structs and enums up above that class before. But in this case, I've actually put a variable as well. The variable doesn't really have to be in the character. For those of you that are familiar with how to access variables, or if you're used to game instances or game states, you may be familiar with some other methods to store variables and grab them from wherever you need them. Doesn't really matter. Long story short, we need to have a value that we can track, we can use in our character, but also that we can use to set up our array here. And so I've just made this constant integer outside of the class. That way I can use it in the structure here. And once you do that, then this will compile, and we can still use this variable in our fighter template character class, believe it or not. So it's useful for a few reasons. But I wanted to show that that's not actually in the fighter template character class. It's specifically above the f input info array. All right. Now let's scroll down. We're going to go to our variables toward the bottom in our class. So just like where we have all the rest of our variables, we had curTick, which was basically it's really the current frame, but I call it curTick because we make it a value between 0 and 59. And so this tracks exactly where we are in our circular input buffer. So when we press an input, it knows to get added to the right frame. Then we had captured input this frame. And captured input this frame was basically determining, have we already captured an input for this frame and added it to the circular input buffer? And that's what we were just talking about. We could only ever do it the one time per frame. Well, since we know that we can now do it more than one time per frame, we need to also know how many there are. How many for this frame have we added? Or how many for this frame are we going to have to check against when we're looking for commands when looping through our input buffer? So to do that, we're going to need another variable, and I've called it int current frame input index. So basically this will keep track of where we are at to know if we need to add another item to the array, and how long we have to go through looping through our input buffer when we're looking for commands, because we can cut out a lot of additional loops that we don't need to save on memory and also to speed up our program. Now, if we go into fighter template character, I set my variables just like always. So I actually had not set curTick or captured input this frame before. Remember, the constructor is a safeguard, so sometimes you'll see me not do it, but really you should be every time. It's also just cleaner and easier to read. So curTick starts 0, current frame input index starts 0, and captured input this frame starts at false. Now we can scroll all the way down to add input to input buffer. This is the function where we take in input, determine if it's forward or backward, determine if it's a press release, all that stuff, and then we check against our command list, like I keep saying, to see if the user has performed a command. Well, before in the series, I actually set this up to where we had done this. We had circular input buffer curTick equals input info. Well, this is the first place we're going to get an error since we changed our circular input buffer. So you can see that we changed our structure to be t-circular buffer of f input info array. So there's an array in here. So the way we access it is a little bit complicated when you first look at it, but really it's not too bad. We're grabbing our circular input buffer at this frame. Then dot inputs. Inputs is the name of our array in our f input info array structure. Inputs. So then we're grabbing that and we're grabbing the proper input from that index. So this frame input 0, or basically the first index in that array. I'm hard coding inputs to 0 here, inputs subset 0, because what this means is this only fires if input was not captured this frame. So basically, if no input has been provided for this frame, then the user hasn't pressed any inputs yet this frame, and thus we need to add the first one to the array. We can assume this is 0. This is the only time this will ever fire, because we immediately set it to true after this, and if it goes back into this function on the same frame, it's not going to go into this if statement. It will go into the else. So we can assume this is 0. Now, the else, I actually commented this right here, and just it never did anything before. Well, now we're going to update it to do something. So we're going to increment the current frame input index, because it's 0 initially, but we already have something at 0. We don't want to overwrite that. And so I add 1 to it, and then I go to circular input buffer curtick.inputs, and then I use this variable that we just incremented and set its data equal to input info, because this statement will only fire if input was already captured for this frame. Increment this value, and then it will set it to what's in input info. So if I press light and heavy on the same frame, it's going to fire for both. Light is going to get the first index, and then heavy will get the second index. Now, another place we have to fix is down below here. So we have this check input buffer for command using type function call. You'll get an error here because we were previously passing in circular input buffer curtick.input status. But remember, we have to grab the input status of the input that we're currently checking against. We want to see if the input buffer has any commands that we can perform. So we need to now use circular input buffer curtick.inputs subset current frame input index .input status. We just want to access the element in that array as opposed to just using circular input buffer curtick. Okay. Now let's go into check input buffer for command using type. So this is our function. This is our most important function for the input buffer, really, because this is where we check against all of our different conditions. Is it a charge attack? Is it a multi-input attack? Have we matched the sequence? Have we done it within enough frames? All sorts of stuff going on in here. You guys have heard me ramble on about this one over and over again because of how important it is and how much work we've done with it. So I'll spare you the effort because we covered it in the last episode in depth as well. So if you want to check out everything about this function, why it works the way it does, you can check it out in the previous episode. Otherwise, I'll just go over what I've added. So before, we did not have this for loop. I'm going to comment out the things we did not have. We didn't have this for loop, any of this. Okay. There are easier ways to do it, but I had to figure out in my head which ones we used and which ones we didn't in the past. So, your function should look just like this, ignoring the commented out lines the lines I just commented. So you should be familiar with this function. Let's add it one step at a time and see what we actually did. So at this point, what I want to do is I want to loop through, for every frame that has more than one input, we also have to loop through those inputs and check against the command buffer. Reason being, say you have an input for a command that's like downright light punch, let's do, because that'll be easier to explain. So if we do down and then we do right and light punch on the same frame, if those two inputs come at the same frame, well, technically with how our system is set up now, it wouldn't actually pick that up, and so that would not be considered a correct command. We need to make sure we're looping through the additional inputs that occur on the same frame to make that work. So the way we can do that is we can loop through every index in our circular input buffer array that has a value. Okay? So by default, they'll all be E input type none and all that good stuff. But if it has a value, let's just start with this first for loop. We'll go to the inner logic in a second. But we're going to add a new for loop, and it's got to be after frame to check because we are going to be using frame to check inside of here. So we need to figure that out first. Okay. So now I'm doing for I, which I is basically just the index that we're going to be using here. So you could call it input if that's easier for you. Basically for I is less than max inputs per frame. That's the constant integer that we made because, well, we know if it's less than that, then there's a possibility that it captured input. If it's more than that, then it's going to be out of the bounds of the array and cause an error. But otherwise, even if it didn't cause an error, then you wouldn't ever find anything. So it'd be worthless to try and loop over it. And then we're going to increment every time. Now, these 3 lines, we were grabbing the type, status, and charged frames from the input buffer. Before, it was just circular input buffer, frame to check, dot, whatever we want, like input type, input status, or charged frames. Now, we have to access it from the array, remember? So we have to do circular input buffer, frame to check, dot inputs, I, dot input type. That way we make sure we also loop through every single input that was added on that frame. Now, this right here would actually work as is, but we don't want to keep looping over inputs where their input type would be none. It wouldn't really make sense because if we were looping over them and they were none, really it would just be wasting time. We don't want the type to ever be none. If we're trying to check to see if it was a correct input or not. It just doesn't make sense to do so because really it's not, the user can't enter none. None is a default state that gets put if no input was provided. And so since that's going to be the case for the majority of the time, you know, every frame you're not going to be pressing 8 inputs, so the vast majority they're going to be just null values or empty. We want to make sure we skip over them. So that's where this new if and else come in here. So let's look at the if statement first. I'll comment or I'll uncomment those lines, right? Like that. And now we get into our for loop and we're going to check each individual frame, right? And we make sure that the circular input buffer frame to check dot inputs I dot input type is not equal to e input type none. So basically there's going to be a value that was assigned here. If that's the case, then we can skip this because we don't want to perform any of this logic on a none input. Okay? And then else, if it does happen to be a none, to skip it, I break out of the for loop. Now, technically, you don't have to break out of the for loop either. This if statement will stop you from doing all this logic on any none inputs. However, we can speed it up even more so by performing this else, because if we break out of the for loop, that basically means we terminate the for loop. It not necessarily just end it, you know, we're not going to go any farther than we've already gone, because at this point we don't have any other inputs. Basically, you can't skip an input. We won't have like the first input on that frame was light punch, the third input on that frame was medium punch. That wouldn't make sense. There's no way to skip an input in the system that we have. And so if we actually get a none value, that we would go into the else, and thus I'm just breaking just to speed up our process even more. Basically, this won't slow down your game at all because we're just ignoring any nones, so we don't have to worry about that special case being taken care of every single frame or anything. Okay. And that's it. You don't have to change anything else in here with anything that we've done. That's actually quite simple. Okay, and now we have to go to tick. So tick is what gets called every single frame. And at this point, we had this in here, where if no input was given for this frame, that means that the user did not enter, or they didn't enter, or they didn't press anything on that frame, in which case we were assigning the none like I was just referring to above. We actually made a fake none input to fill out the data, and we were setting circular input buffer cur tick to none input. Just like all the other cases, you will have to update this to be circular input buffer cur tick dot inputs. I use subset 0 because if no input was given, then none of the values were filled out, so we can assume that it's 0. and we just set that to none input. Else, though, if captured input this frame, we were setting captured input this frame back to false. Basically saying, you know, if we received input for this frame, that's great, but as we go to the next frame now, we're not going to need that again. So we might as well set this to false. I think that makes sense, and we've been doing that for a long time now. However, one other thing we do need to do is reset the current frame input index back to 0. Because if we don't do this, then the next time that we perform multiple inputs on a certain frame, it's going to grab the current frame input index, and it's going to use that. So say we held 4 inputs on one frame. They would then go to current frame input index would then be 3, because it would be 0, 1, 2, 3. That's 4 inputs. And if I did that, then, and I didn't reset this afterward, then the next time I went to do multiple inputs on the same frame, it would go to the wrong index. So we need to make sure we reset it every time that it was changed from 0. It only gets changed from 0 if this is true. So you can just go ahead and set it back to 0. The rest of the stuff should all look the same. Don't have to change any of it to make any of this work. And now we are good to go. We can go back into our game. Go to Versus. Play our stage. And now when we're here, we should be able to do everything that we could already do. I'll throw up the output log again. So just one final test since we're done with multi-input presses after this. I can perform regular attacks, crouching attacks, jump attacks. I can perform directional attacks. Attacks with multiple inputs at the same time. Attacks and inputs will still work if they were performed on the same frame. I can do charged attacks. And I can do standard commands. And at that point, we can do pretty much everything that we need to be able to do to actually make everything work in our input buffer. There are 2 other things I would like to cover that will have their own episodes, so let's look at them now. So, and by the way, I say 2 other things. There's plenty of other things I want to cover, even more so with the input buffer, but I think 2 major topics that I still want to cover with them. Let's go into practice mode real quick so I can show you what I'm talking about. So you can see here how whenever I perform an input, like even if I do down and right at the same time, or theoretically on the same frame, like this. See how that was literally on the same frame in the output log, but they still got added one after the other? Sometimes games will actually show you them on the same row. We could cover how to set that up and make it to where, you know, inputs either pressed on the same frame, or if they were multi-input commands that were executed, we can show these input stack icons in the right spot, you know, on the same row here. Different columns, same row. The other thing that I would like to make a video about is, well, we need to smooth out controller inputs as a whole because it is a different beast. Similar, but there are some things that are unique about it. However, one thing that we haven't really covered, and you can't really do on keyboard other than a very specific input of down, right, and down, and then right to do quarter circle. On a controller, if you want to perform quarter circle, you have to move the axis and capture the values and watch where it's going so that you know which inputs you can put in. So we need to be able to handle things like quarter circle input, and we can't currently do that, at least not to the full extent that we should. So that'll be another input buffer topic that I want to cover. But anyway, guys, that's really all I got for you today. It's a pretty simple episode, but this wraps up our multi-button inputs quite nicely and our multi-input commands quite nicely. So I think we just wrap it up here and we'll call it good. So anyway, if you enjoyed and this helped you, please subscribe. It does more for myself and the channel than anything else you can do, and it's completely free. I want to give a huge, huge shout out to my Patreon members and YouTube membership subscribers, guys. Thank you so much for the love and support. I really, really appreciate it. And we're on episode 101 of the fighting game and still going. plenty more work to be done. So I hope you follow me around for 100 more, because the series is so incredibly enjoyable to work on, and I'm glad you're enjoying it as much as I am. If you did have any issues during this episode or any of my tutorial series, then feel free to join the Discord community. There's a link in the description. It's completely free. I'll be happy to help you with anything that I can. But like I said, guys, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.